You said 10, right? F of x equals, oh, no. If I look at the right paper, it always helps. Oh, Leah, this is the one we were just doing, isn't it? Okay, almost called you Hope. I did that the other day. I was talking to Kenzie, and I said something about Hope, and she said, who? I said, Hope. And then I stopped and I went, Leah, Leah. Okay. Yeah. I would never say that. All right, so algebraically, the zeros, if I set this equal to 0, I get 1/2 times the square root of x minus 3. I can divide by a half or multiply by 2. I prefer to multiply by 2 because to me it's here. So if you multiply by 2 and that goes away, I get 0 equals the square root of x minus 3. Yes? Yeah. That would be subtracting, and you can't subtract because it's multiplied. You have to do the opposite of what's being done here. Yes. Yes. Right. All right. So now let's go. Yeah. Yes. 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 To get rid of it. If it's multiplied and it's a fraction, flip it and multiply to get rid of it. Now I'm going to square both sides. What is 0 squared? 0. So what does that do? So the x-intercept is 3. Graphically, if you look at it, and let me tell you why, if you tried it on your calculator, you probably had issues. When you graph this on your calculator, it looks something like this. Nope. It still should have done like, okay, let's graph it together, boys and girls. Oh, wait, no. I'm looking at 8. My bad. Mine look like this. Like, isn't that this? Oh, Stacy, get your stuff together. That's what it should look like. Let me get all my cameras hooked up here. All right. Number 1, when you put a fraction into your calculator, make sure it is in parentheses. So 1/2. Then I need the square root of, what was it, x? I forgot now. Minus 3. Then 6. That's what it should look like. Now, if you try to do second trace and you try to calculate the 0 here, here's the problem. What your calculator does, remember yesterday I told you to watch where it changes from positive to negative or negative to positive. The problem with this one is that's just a point right there on the x-axis. It never changes. So your calculator's not going to recognize it being a 0. So you have to just know enough about this to know that that point is at 0. Y'all remember in Algebra 2, I almost didn't even finish that question. When we did function transformations and we took a parent function and we transformed it, we slid it, we shrunk it, we reflected it, we did all that. So this parent graph is the square root of x. Square root of x, and we did a unit on radicals. We did square roots and cube roots. Y'all remember that? Square roots looking like this, cube roots go off in both directions like this. So the parent graph here goes 0, 0, and 1, 1. Remember, you had to have a starting point and a direction point, and we go like this. The only thing that this has done, besides the shrink or stretch here, is it's been slid to the right 3. 1, 2, 3. So that's why that point sits there. Right. So y-intercept is whenever you put a 0 in for x, right? So if I put a 0 in for x here, so what I'm really doing is f of 0. I get 1/2 times the square root of 0 minus 3, which is 1/2 times the square root of -3. What does that mean? Why? It's ugly. You can't have negative under there. This gives me that imaginary I. It's got the I in there. We're not graphing I's. So if this happens, we're just graphing real numbers, right? That means there is no y-intercept. No or none for the y-intercept. If you look at the graph, that makes sense, right? This is my graph. Does it ever cross the y-axis? No. And that's why. Number 8. Yeah. If you put a 0 in for every x there. Which one? Okay, what do you want me to find out? You want me to show you how to factor that one? Is that what you're asking? Okay. Number 9. So number 9 is one, when we saw this form in Algebra 2, it was when we did the polynomials unit, but we said there were special kinds of polynomials that you could factor, Harris, the same way that we did quadratic. And that was if it was in what we called quadratic form. And quadratic form means even degree, that's the biggest exponent. This one is half of that degree, and this is a constant. And if that happens, then it's an easy factor for me because I can factor by slashing the same way I did before. So in other words, what multiplies to 16x to the 4th, but adds to negative 17x squared? Negative 16x squared and negative 1x squared. I'm going to come in and rewrite this. Minus 16x squared minus x squared plus 4.
The interruption, but at this time, 10th graders should report to the auditorium for the ring ceremony presentation. Again, that's 10th graders to the auditorium at this time for the ring ceremony presentation.
I keep thinking that that's y'all because I'm not used to y'all being juniors yet. Huh? It is Peyton. All right, what can I take out of the first two? Of 4x squared, what's left? The middle sign always stays. What can I take out of the last two? 1. And that makes the last sign change. So I end up with x squared minus 4, 4x squared minus 1. And now I can factor all of those as difference of two squares. So I have x minus 2, x plus 2, 2x minus 1, 2x plus 1. Now it's completely factored and it's easy to get my zeros here as well. 2, negative 2, 1/2, negative 1/2. Have you set each piece to 0? Yeah. All right, y'all ready to switch gears? It's really not. It's the other half of the lesson that we didn't do yesterday. All right. Thomas, are you sure you're not sick? All right. Armando. Dang. Let's say it together. Dang. 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 It's okay. Critical points. We're going to find these using a calculator. I know, I'm sorry. Yeah. We're going to do critical points, increasing and decreasing intervals, and end behavior. And that's it. As x goes to. All right. What's a critical point? There are two types of critical points. One we're going to find today. The other one we're going to learn about a little bit later, but I need you to know what it is, and we're going to talk about it. We'll have you estimate it today. The first one are maxes and mins. Okay? Y'all know how to do that, right? Those are hills and valleys, right? Tops and bottoms. Yes, it calculates it for you. Okay, so we're looking at, now there are different types. Remember, we can have an absolute or a relative. Everything is a relative. Everything is not necessarily an absolute. Relative just means it's a high or a low in a certain area, right? But absolute means it is absolutely the highest or the lowest on the entire graph. So if I have something that looks like tell me what this point is. A relative max. How about this one? It's relative. Why is it relative? Those arrows say that my graph goes down forever and ever, so I can't say it is absolutely the lowest point, but it is a low point within that certain vicinity right there of the graph. How about this point? Absolute max. I could still call it a relative max because by definition it's still a high point within that area right there, but it's also the absolute. It's kind of like a square is a rectangle, but a rectangle is not a square kind of thing. So it's still a relative, but it's also an absolute. So we call it the absolute. Okay. What is special about these highs and lows? If I am trucking along this graph, we read a graph the same way we read a book, left to right, right? If I am coming left to right, then my graph is going what? Up or down? Up, right? Here I'm going up. I'm going to say that that is an increasing interval. Do y'all remember doing this in Algebra 2? Okay. And then from this maximum to this minimum, as I move left to right, what's going on? Decreasing. So this interval is decreasing. And then again, when I hit this relative minimum and up to this absolute max, what is the graph doing? Increasing. And then it starts decreasing again. And so for this reason, because if you look, it stops going up and starts going down, we call these sometimes, y'all remember? Turning points. It's where the graph turns. Okay, it's where it turns and changes direction. You always read it left to right, just like you read a book. You know how you read a book from left to right? You read a graph from left to right also. Okay, so I don't even have a smart response for that. I don't know. All right, the other type of critical point, this one we are going to come back to. We are going to use our calculator. We are going to find these points, and we're also going to label these increasing, decreasing intervals. I'm going to just go ahead and show you the other kind of critical point, and then we're going to come back to on the calculator to show you what this looks like. The other kind of critical point, and we do this a lot in calculus, and we will hit on it in here some, are what we call points of inflection. Did we talk at all about this in Algebra 2? Did we talk at all about concavity in Algebra 2? Okay, sometimes I hit it and sometimes I don't. Points of inflection. So to understand points of inflection, you have to understand concavity of a graph, okay? Do y'all know what concavity means? Yes, it's kind of the same thing, only with math, we say it's either concave up which has I think of it like a bowl. Like it's got, I mean, it won't be this pronounced all the time, but think about it like it could hold water if you poured water in it, right? That's concave up, concave down. If you poured water on it, it would fall right off, okay? Bless you. Where this concavity changes is what's known as my point of inflection. Okay? So where it stops being concave up and starts being concave down, or vice versa, that's the point of inflection. Now, these are a little bit harder to tell, but if you look at my pink graph up here, can you tell at least this first little bit here, that would be what? Concave down. Can you tell that this little part, concave up? So somewhere in between, it's changing. Do you agree? So I'm going to just kind of estimate maybe in the middle, and I'm going to call this a point of inflection because my concavity changes somewhere in there. And for right now, all I want you to be able to do is tell that the concavity changes and just put me a point between to say you estimate this to be a point of inflection. Okay? Over here, or at least tell me how many points of inflection a graph has. How many does this one have? 2. I'm concave down, I'm concave up, I'm concave down, and I never change again. So somewhere in between here is another point of inflection where I change from being concave up to concave down. Does that make sense? Okay. Now all that's left is to find the maxes and mins on our calculator. So here we go. This is what you're going to have to do. Did I give you the graphs on the back of that? Oh, see, you're not even, well, you'll still have to graph them, but at least you don't have to hand graph them. Well, I don't have a lot of them. There's just a few. Here's what I want us to do with this one. I want us to find the exact maxes and minimums. I want us to tell if they're relative or absolute. I want us to find the increasing and decreasing intervals in interval notation. And then I want us to label the approximate points of inflection. Okay, and for this one, I would give you the graph, or I'll give you the graph on the homework. So it's going to look something like this when you graph it. Okay? Because it's on this little paper right here. And I'm basing a graph on my calculator. The genuine concern, because I did pop that on there fairly quickly. Yes. Put the equation back up. Max's, min's, increasing, decreasing intervals, estimate points of inflection, and we'll label concavity too while we're here. We'll just do everything in this one. All right. Let's graph this bad boy on our calculator. This one's not from your paper because I don't have a lot. This one is from a practice paper I have up here. We're not finding the zeros on this one now. X to the fourth plus x to the third minus 4x squared plus 1. Zoom 6. Uh-oh. I do not. I'm sorry. I've got some ordered, but they're not here yet. All right, so let's do maxes and mins first. Now, yeah, Zoom 6. Your maxes and mins, if you think back to Algebra 2, they are found the exact same way that the zeros are. And y'all struggled with this a little bit, so let's see how we do with this. I'm going to choose this point first. That's the first one I'm going to find. Is that a max or a min? That's a min. So I'm going to go second trace. Oh, no. And go to minimum. And hit enter. All right, again with the left bound, right bound stuff, right? But it's a little bit easier to see, in my opinion, when you're talking about a max or min. So I'm going to go down, and unfortunately my words are going to be a little bit on top of this. There we go. That's about where my minimum is, somewhere in there, but I need to be to the left of it. So I need to make sure I click left until I'm clear of it, right? And I hit enter, and you'll notice that this little arrow pops up again, because again, you're giving it an interval and it's finding the lowest point between those two arrows. So it needs to know where to look between. So I give it a leftmost point, then it says right, so I scroll to the right until I'm sure I'm past it, and I hit enter again. So now you see my two arrows. So it says I'm going to find the lowest point between these two areas. And you hit enter, and it gives you the point. Did everybody get that point? Yes. Hit enter, and the arrow pops up there. Yes. Yes, negative 7.3. I will tell you, since this is pre-cal and we're getting ready for calculus and everything, take everything out 3 decimal places at a minimum. Calculus readers will not give you your answer point if you round prior to 3 decimal places, as crazy as that is. So I would say that this minimum, this is an absolute minimum. I should probably do this on here. This is an absolute minimum, and the point would be negative 1.838, comma, negative 7.310. You gotta take it out 3 decimal places. All right, y'all take a second. Y'all take a second for me and find this maximum and this minimum, and let's see if we all get the same thing. Second trace. Yes. If what has an exponent? Yes, yes, yes. You do 0, 1. No, anytime that you've got an E with a negative number, you make that 0. All right. Did everyone find the correct maxes and min? No? Remember, if you get something that's E with a big negative number that follows it, that is 0. If it was positive, that would be infinity. You won't get one that's positive. You with us? Okay. It was like E to the negative something. You didn't get that on your... I got that on. Oh, yeah, make sure you get it. All right, I want to make sure everybody can get this before we move on. Shit, but okay. That first one's still 0. Because it's E. You see that E with a negative number? You don't? Oh, yeah, that's 0. Anytime it does, this number might be a little bit different, but if it follows with E negative something, it's 0 every time. Yeah, so that's why. All right. 0, 0. If you see the E with a negative number, that is 0. It just means 0. It's scientific notation. It means move the decimal to the left 6 times. 0.000001. So it's 0. Yep, the whole thing is 0. Oh yeah, just the X, just the X. So the point is 0, 1. You see how I wrote the point on here? The point is 0, 1. All right. Let's do the increasing, decreasing intervals. Now, when you write intervals, you write them using the X values. Okay, always the X values, because you're reading it left to right like you read a book. And which axis runs left to right? The X axis. So for my increasing intervals, where is my graph going up as I move from left to right? Between here and here, right? Using those X's, how do I say that? Negative 1.838, and I do brackets on these until I get to 0. Is it increasing anywhere else? Yes, where? The right of this minimum, right? So from 1 point, so I do my U from 1.088 to infinity. Okay, those are my increasing intervals.
If you would have explained it just like this when I first learned it, I would have such better. I would just be like, I would cross the line.
Do what? So I don't really agree from a calculus standpoint that it should be brackets. I think it should be parentheses, because technically calculus-wise, that's the point where it's neither increasing nor decreasing. It's changing direction. Its derivative is 0 and all that. But they say use brackets, so we'll just go with them. Infinities always get parentheses no matter what. Yep. Say it again. What is what? Oh, the U just joins those two together. It's every time you join intervals, you put them a U. It means union. But you don't have to know that. Just know that you join them with a U. But she's right. When it's a U, that's concave up. It means it can hold water in this. It's decreasing from where?
From one.
Huh? No. Show you. Yes, always X's. It's negative infinity because I'm reading it left to right, right? And I start out on this graph. This graph is decreasing here as I move left to right. It's going down as I move left to right. It's still based on X. All these intervals are based on X. So I'm going to do negative infinity until I get to what? Negative 1.838. Any place else it's decreasing? This little piece right here, from the 0 to the 1.088. So you're using your max. Once you find the maxes and mins, they give you all the information you need. Now tell me this while you're here. How many points of inflection would this graph have? About 2. It would have 2 because here, what's my concavity? This is concave up, concave down, concave up. So how many times does it change? 1, 2. I will tell you your points of inflection. Your points of inflection will always be 1 less than your number of maxes and mins.
What's that?
Your points of inflection will always be 1 less than the number of maxes and mins that you have. That's it.